Hello, class. If you missed today's lesson or you just want to review what we went over, this video is for you. Now, this video is all about finding the constant rate of change. So, what do the constant rate of change and Snoop Dogg have in common? I bet you'll never guess. They both have multiple names. Now, here are some of Snoop's favorite names, and here are some of my names and all mathematicians' names for constant rate of change. Its most common other name is slope, but of course, it's also called constant rate of change, unit rate, or common difference, if you remember that from our last lesson. So, a rate of change is the rate that describes how one quantity changes in relation to another. So, it's a relationship, an algebraic relationship. When you have a constant rate of change, that means you have a linear relationship. Now, you see that word line right there in linear. That means if you graph this relationship, you'll end up with a straight line. We call that linear. All right. Now, in linear relationships, the constant rate of change is how y is changing versus how x is changing. And to calculate that, we look at the vertical change. We know that y is up and down. So we know it's up and down. And so we're going to be looking at the change in y values versus the change in x, which is left to right. So we're going to be looking at that. And so change horizontally. So here we go. Um, we will calculate that change in y and divide it by the change in x. This is another way of writing that you will see. And we call this delta because this is the Greek letter for d. Delta y over delta x. And when I say over, you see this division line here. That means we're going to divide this number, change in y, by the change in x, another number. All righty. So let me get rid of this. Okay, so now we're going to take a look at the change in y versus the change in x. To calculate the change in y, we're going to do 4 minus 2. So what is that? Well, that's going to be 2. I think I'll do one more entry just to be sure. What's 6 minus 4? Ah, it's 2. So I think I can pretty safely say here the change in y is 2. Let me get out of this. Sure why this isn't working? Yeah, it's 2. So now I'm going to do the same calculations for x. Let's use a different color for that. 2 minus 1, that's 1. 3 minus 2, that's 1. I really only need to do a couple. I don't need to do these over and over again. I can do 1 or 2 to get my constant rate of change. Now here we see that our constant rate of change is 1. Our change in x is 1. Now I'm going to do the calculations. I know that my change in y is 2. I'm going to divide that by my change in x, that's 1. And when I divide 2 by 1, I get the answer 2. So my constant rate of change is 2. Now, it's important to talk about what these things mean in the context of a problem. We are comparing students to the number of textbooks. Students to the number of textbooks. So that means the number of textbooks increases by 2 for every 1 student. Let's get rid of that stuff. Go on to the next slide. All righty. Okay, let's look at another example. Now, in this example, when I calculate the rate of change, the change in y, I'm going to, let's see here, I'm going to subtract negative 12 from negative 20. In other words, I'm going to put in my calculator negative 20 minus negative 12. And I get the answer negative 8. I'm going to check one more. Not that it will necessarily be the same, but that doesn't mean it's not a constant rate of change. But let's check. How about we subtract negative 20 from negative 28? In other words, we have negative 28 minus negative 20. And when I do that, I get negative 8. All righty. So let's go over and see. So I think this tells me that my change in y is negative 8. But let's check our change in x's because we can't find a constant rate of change without that. So I'm going to do 5 minus 3. Well, even without my calculator, I know that's 2. How about 7 minus 5? Even without my calculator, I know that's 2. So I think I can safely say that the change in x is 2. All right, so that means my change in y is negative 8, and my change in x is 2. I think I have an issue here. Let's see. Can I fix that? Not real sure. So this should be negative 8, and the constant rate of change should be negative 4. So make that change if you are taking notes. Not sure how to get back to my pointer thing, so I can write on the slides here. But hey, I guess I'll figure that out later. But this is negative 8, and negative 8 divided by 2 should be negative 4. So don't make the math mistake that I made on my slide. I do want to point out one thing here, though. I want you to notice that, the change between negative 40 and negative 28, that is not negative 8. As a matter of fact, if I go negative 40 minus negative 28, I get negative 12. Well, let's take a look at the change in y, x, I mean. So negative 12 was the change in y here. But if I take a look at the change in x, I get 10 minus 7, that's 3. Well, I want you to notice that negative 12, which is the change in y, divided by 3 is negative 4. The same answer that we got over here if you made that correction in your notes. Now, again, I want to take a look at the meaning because all math is applied to real world problems. And here we're comparing the number of children to milliliters of some liquid. Who knows? So the number of, that should say milliliters, is decreasing by 4 milliliters per child. That's what this means. Okay. All right. Let's look at one more. So we have the number of students and the number of pencils needed. So we are going to go right along like we were. We are going to determine the change in y. And this time I'm only going to check one y value. One. I'm going to look at the change between 30 and 15. 30 minus 15 is 15. So I think I'm good to go. I know my change in y is 15. And then 10 minus 5 is 5. So I know my change in x is 5. Now I'm going to determine my change in y divided by my change in x. So I got 15 over 5. I'm going to fill in my values. I know that 15 divided by 5 is 3. Now, what does that mean? It means the number of pencils needed increases by 3 pencils per student. That's what it means in the context. Now, I hope you notice I didn't check all the way down. I don't need to. I just need to check one. Everything we're giving you in this unit is linear. So if you check one, the first one, and do these calculations, you will find the constant rate of change. Now, determine the constant rate of change, which, by the way, is also the slope for our line for this table. All right, so, okay, I'm going to stay with my process of determining the change in y. So -7 minus -1 is going to end up being -6. That's the change in y. Now I'm going to look at the change in x. 12 minus 4. That's going to end up being 8. All right, so I have a positive number for the change, or negative number for the change in y, and a positive number for the change in x. When I fill in the blanks here, change in y divided by the change in x, I get -6 divided by 8. And when I reduce that fraction, then I get -3 over 4. Now, it makes sense that it's a negative constant rate of change or a negative slope because I was dividing a negative by a positive. So the constant rate of change is -3 over 4. That means for this scenario, the number of gallons decreases by 3/4, -3/4, that negative means it's decreasing, going down for every adult. So here's the really good news. Now that you know how to find the constant rate of change from a table, you also know how to find it from a graph. Uh, how are you going to do that? You're going to make a table. You know how to do tables. And from 2 coordinate points. How are you going to do that? You're going to make a table because you know how to find constant rate of change from a table. So let me demonstrate. We have this graph right here, and we have lots of points on this graph that are what I call pretty points. By that, I mean exact points. Let me show you an example of something that's not an exact point. That's not an exact point. It doesn't go exactly through the grid. However, this point right here, 0, 0, that's a pretty point. It goes exactly through where the two lines on the grid intersect. This is a pretty point. This is a pretty point. I can pick any one of those pretty points, and I need 2 of them for my table, and use them. So here I'm going to pick 0, 0. X equals 0, y equals 0. And for my next pretty point, I'm going to pick -2 for x and 1. I just need to pick pretty points. So I did. I need two of them. I only need two of them. Once I have two of them and they're in a table like this, I know what to do. You know what to do. I'm going to calculate the change in y and the change in x. So I'm going to calculate 1 minus 0. Well, that's easy. That's 1. Then I'm going to calculate negative 2 minus 0. That's easy. That's going to be negative 2. And then I'm going to divide my change in y by my change in x. And when I do that, I get 1 divided by negative 2, which is negative 1/2. The constant rate of change for this graph, or the slope for this graph, is negative 1/2. All right, let's look at another example. I got a graph. Maybe I know how to find constant rate of change from the graph itself. Maybe not, but I do know how to make a table. I need pretty points. So I chose 0, 0 because it's exact, and x equal 1, y equal 10 because it's exact. Now I'm going to find the change in y, which is going to be 10 minus 0, or 10. The change in x, which is going to be 1 minus 0, which is 1. Then I'm going to calculate 10 divided by 1. The constant rate of change is 10. It's not a fraction like the other one. It's a whole number, 10. Okay, now what if I just had 2 points? I don't even have a graph. I don't even have a picture. I don't have a table. Well, you know what? As long as you have 2 points that are on a linear function, you can make the table yourself, just like you did for the graph, only this time you don't have to find the points. We tell you what the points are. So I'm going to make my table. I'm going to use 3 and 2 and 12 and 8. Now you notice that the x values are always in the x column and the y values are always in the y column. And then I'm going to do what we did on all those table examples. I'm going to find the change in y, which will be 8 minus 2. That's going to be 6. And then the change in x, 12 minus 3. That's going to be 9. All right, then I'm going to divide the change in y by the change in x and reduce the fraction to 2 over 3. The constant rate of change is 2 over 3. That's because I had a fraction. Delta y is 6 divided by delta x is 9. 6 over 9 reduces to be 2 over 3. Now, if you're terrible at reducing fractions, don't worry about that right now. We can talk about that in class, how you can do that quickly and easily. Right now, just worry about getting the correct constant rate of change, also known as slope. Okay, one more example of this. Now, we got 2 points. We got 2 points. We can always make a table. So I'm going to plug these 2 points into my table. I'm going to find the change in y because that's always what we do. I hope you got that now. So I'm going to do negative 7 minus 28. I think that's going to be negative 35. Yep. Ah. And why did I not have a negative here? I don't know. And then a change in x is 2 minus negative 8. So that's going to be 10. Let's see here. So I have negative 35, should be negative 35, divided by 10. So it's going to be negative 7 over 2. The constant rate of change is negative 7 over 2. All righty. Now, um, The last thing that we have to do is determine the constant rate of change for the linear function represented by equations. Like if we have equations, we can find the constant rate of change. It's the same thing as a slope. So suppose we have this equation here, y is equal to 3x plus 2. Well, that's in the format of y equal mx plus b, where m is always the slope. M is always the slope or the rate of change. So I'm not even worried about this. If I want to know what the constant rate of change, I'm looking for the multiplier on x, and that would be 3. So the constant rate of change or the slope is 3. So if I have a y equal mx plus b equation, this is super easy. But what if I don't? What if I have something in this weird format? Well, then I need to put it in a y equal mx plus b format. That means I need to isolate y. Now, to solve this equation for y, I would add 2x to both sides. That will cancel out this negative 2x and cause a positive 2x to be on this side of the equation. Then I would divide both sides, everything on both sides of the equation by 3. So now those 3's cancel out, and all I have left is a y. Here I have 2 over 3 times x. And here 21 divided by 3 is 7. Well, now it's in y equal mx plus b form. That m multiplier on x is the slope, also known as the constant rate of change. That's 2/3. The constant rate of change for this particular equation is 2/3. I know this is a long video. Before we go, you may have noticed that both of the graphs in this lesson pass through 0, 0, the origin. Both of them did. And that where the graph touches the y-axis, you know this is the y-intercept. It's the b in y equal mx plus b. And you know they had a constant rate of change because we found it. Guess what? That means you already know something you're going to need to know in a couple of lessons, and that is direct variation, which is any linear function that has a constant rate of change, which they all do, that has a y-intercept of 0. That is a fine example of direct variation. So congratulations, you have a head start on your next lesson. For now, peoples, that's all. I appreciate your attention, and I hope this helped if you missed the class. Bye-bye.